I'm Anil Kumar, and on request of my students, I have taken a few questions from the textbook Nelson on calculus and vectors. Here is question number 28, page 84, and this particular question is especially for my student Ryan. The question here is, for each function, sketch the graph of y equals to f of x and find an expression for f dash x. Indicate any point at which f dash x does not exist. So we have three particular parts in this. All three are kind of piecewise functions. So f of x equals to x squared when x is less than 3, or x plus 6 when x is greater than or equal to 3. F of x is absolute value of 3x squared minus 6, and f of x equals to absolute value of x minus 1, correct? So that is the question for you. So let us try to understand how to do such questions. I will solve the very first part here and these two in the following videos, provide you with a link for their solutions also, right? So we have the function f of x equals to x squared where x is less than 3, and it's a straight line x plus 6 where x is greater than or equal to 3. So we have one part which is a parabola opening upwards, the other one is a straight line. So what we can do is, let us first sketch it, right? So first part is sketch the function. So let me sketch this function. Okay, so we'll provide a very rough sketch here. Let us say that this is my x-axis. So let me just draw some lines here. 1, 2, 3, okay, 4, 5. Okay, that's fine. Now, if I write x as equals to 3, then what point do I get? So that's it. This is my 0, 1, 2, and this is 3 for me, right? So if it is on the left side of 3, it's a parabola. On right side, it is that straight line. So when say x less than 3 is a parabola. So if I write 3 here, let me do the right side first, since we are including point 3 on the right side. So I get 3 plus 6, which is 9. So let us say this value is 9 for us, okay? Filled in. So I have this value, which let me write this as, let me use 9. Okay, that's fine. So on y, I get 9. This is for x equal to 3. So if I write 4 here, let's say, it's a straight line, I just need 2 points. So if I write 4, I get 10, right? So that is 10, let us say, for us. So like this. So what we see is on the right side, it is a straight line. Correct. On the left side, we have a parabola which opens downwards, kind of like this. So if I have x equals to 3, I get a point 9, which is same. So this one, okay, let me use a different ink, similar. Okay, so this one is a hole here for x squared, but the point is 9. This is a parabola, so I know if x is 0, I know that's the point. So from the symmetry, we know at minus 3 it will be 9. So let me sketch this parabola, right? So it's a rough sketch. In your test, you should do a better job than this. So that is what we get. And I'm calling this as my function f of x. Okay, so this is f of x, and we have x on the horizontal axis. So for each function, sketch the graph of f of x and find the expression for f dash x. So graph is there for you. We need to find an expression for f dash x. Since it is a piecewise function, we should always, we'll get two particular derivatives. So fx is given to us. So what is f dash x? Let us see that part. F dash x is equal to, the derivative of this will be 2x, the power rule, correct? When x is less than 3. And it is equals to just 1 when x is greater than or equals to 3, right? So that is your derivative. So derivative when less than 3 is a straight line, 2x, and it's a constant value of 1 when it is greater than 3. So let us now sketch the derivative on this graph. So okay, let us do that in this ink. So f dash x. So on the right side of 3 it is 1, right? So let me just say this is 1 for me, okay, and then it is on the right side it is 1. If I write 3 here, I get 6. Do you see that? So it is not the same. Therefore, the derivative does not exist at 3. Do you see that? So the f dash x, we should say greater than 3 is 3. And we also find that it does not exist at x equals to 3, since these two values are different. Do you see that? So that is why. So here we have put a hole, since f dash x does not exist at 3. Okay. So on the values greater than 3, it's a straight horizontal line. On the values which are less than 3, it is 2x. So at 3 it should be 6, correct? So let us say this is 6 for me, right? So another hole here. When x is 0, it will be 0, right? So I'll just draw a graph of a straight line kind of like this. So since connecting them, we get a straight line. So on the left side of 3, it will be this line. So that is the graph of my function, f of x, the piecewise function which I have shown here, right? I hope that gives you a clear idea of how to do such questions. Always in these questions, you need to check limit at this junction where they are combining together, whether the left side limit of the tangent. So we define slope or f dash x as equals to limit h approaches 0, f of x plus h minus f of x over h, right? So in this particular case, whenever you're doing piecewise function, you have to check limits for the function from left side and from the right side. And if they are not equal, then we say it does not exist, right? Does not exist. Just as you saw here, right? If I substitute x as 3, I get a value 6 here, right? And if I substitute x as 3, I get 1 here, and they are not equal, right? Therefore, it does not exist. I hope the point is clear. We'll further explore this with part B and C, and then the concept will be absolutely clear. I hope that helps. Thank you and all the best.